the number of telephone lines busy at an instant of time is a binomial variate with the probability 0.1 that a line is busy. If 10 lines are chosen at random, what is the probability that first point no line is busy, second case all lines are busy, third case at least one line is busy, fourth case at most two lines are busy. So, here in this problem x represents let x denotes the number of lines busy, number of telephone lines busy. So, here x denotes the number of telephone lines busy. So, now probability of telephone lines busy, that is P, is 0.1. So, P means it is the probability of telephone lines busy, that is P equals 0.1. So, Q means probability that telephone lines are not busy, that is P plus Q equals 1. So, Q equals 1 minus P, that is 1 minus 0.1 equals 0.9. So, P is probability of telephone lines busy, Q is probability of telephone lines not busy. So, if P is 0.1, Q is 0.9. So, now how many telephone lines we are taking? We are choosing 10 random telephone lines. So, n equals 10. So, now probability function for binomial distribution is P of x equals n c x into P power x into Q power n minus x. So, n is 10. So, 10 c x into 0.1 whole power x into Q is 0.9 whole power 10 minus x. Now, first case no lines is busy. So, no lines is busy means probability of no lines busy, that is probability of x equals 0. Probability of x equals 0 equals 10 c 0, 0.1 whole power 0, 0.9 whole power 10 minus 0. So, use the calci. So, we get 0.3487. Now, second case all lines are busy. So, all lines are busy means we are taking 10 random lines. So, all lines are busy, probability of all lines are busy means probability of all lines are busy, that is equal to probability of x equals 10. So, put x equals 10. So, that is equal to probability of x equals 10 equals 10 c 10, 10 c 10, 0.1 whole power 10, 0.9 whole power 10 minus 10, that is 0. So, after simplifying using the calci, use the calci. So, we get 0.1 whole power 10, that is 10 c 10 is 1, 0.9 whole power 0 is 1. So, we have 0.1 whole power 10. Now, probability of at least one line busy. So, at least means minimum one line should be busy or more than one lines, means one line or more than one line. So, that is probability of 1, probability of 2, up to we have to take probability of 10, because we have chosen 10 random lines. So, at minimum there should be one line busy or more than one line, that is probability of 1, probability of 2 up to probability of 10. So, if you calculate the probabilities, it will become very lengthy. So, instead of that we have to take its complement. Its complement is 1 minus probability of 0. So, probability of at least one line is busy means x greater than or equal to 1, that is 1 minus probability of x greater than or equal to 1, which is equal to 1 minus probability of x less than 1, its complement. So, 1 minus x less than 1 means x equals 0. So, 1 minus probability of 0, x equals 0. So, already we have calculated probability of x equals 0, 0.3487. So, 1 minus 0.3487, that is equal to 0.6513. Now, fourth case, probability of at most 2 lines busy. So, probability of at most 2 lines busy means maximum 2 lines should be busy, or 2 lines and also less than 2 lines. So, that is P of x equals 0 plus P of x equals 1 plus P of x equals 2. So, maximum there can be 2 lines busy, not more than 2 lines or less than 2 lines. Maximum 2 lines, 2 or less than 2 lines, that is probability of x equals 0 means no lines busy, plus probability of x equals 1 means there can be 1 line busy, plus probability of x equals 2 means there can be 2 lines busy. So, probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. Probability of x equals 0 we have already calculated. Probability of x equals 1, that is 10C1 into 0.1 whole power 1 into 0.9 whole power 9 plus probability of x equals to 10C2 0.1 whole power 2 0.9 whole power 10 minus 2, that is 8. So, probability of x equals 0 already we have calculated, you can use that value 0.3487. So, after simplifying we get 0.9298.
Sample of 8 lamps are inspected. What is the probability that one or more lamps are defective? So here probability of defective lamps is given, that is P. P is the probability of success. Probability of a defective lamps, that is P, is given by 5%. So 5% means 5 by 100, that is equal to 0.05. If P is the probability of defective lamps, then Q is the probability of non-defective lamps. So we know that P plus Q equals 1, therefore Q equals 1 minus P. So now probability of a non-defective lamps, that is Q, equals 1 minus P. So 1 minus P is 1 minus 0.05, that is 0.95. So now by binomial distribution, the probability function is P of x equals NCx P power x Q power n minus x, but here n is 8 lamps and where x denotes the defective lamps, where x denotes a defective lamps. Now probability, we have to find probability that one or more lamps are defective. So probability of one or more lamps are defective equals, so we have to find probability of 1 plus probability of 2 up to probability of 8. So if you calculate P of 1, P of 2 and P of 8, the calculation part will become very lengthy. So instead of that, we have to find its complement. So its complement is 1 minus probability of 0. So that is equal to P of 0 means x is 0. So 1 minus of n is 8. So 8c is 0, P power x, that is 0.05 power 0, Q power n minus x. So that is 0.95 whole power 8 minus 0, that is 8. So now using the calci we get 0.3366. So thus Thus the required probability or probability of one or more lamps defective out of 8 is 0.3366.
The probability that a pen manufactured by a factory be defective is 1 by 10. If 12 such pens are manufactured, what is the probability that first case exactly 2 are defective, second case at least 2 are defective, third case none of them are defective. So, now here by binomial distribution, so here probability of a defective pen is, that is P. So, probability of a defective pen P is given 1 by 10, that is 0.1. If P is probability of a defective pen, then Q is probability of non defective pen. So, we know P plus Q equals 1. So, Q equals 1 minus P. So, probability of a non defective pen, that is Q equals 1 minus P. So, Q equals 1 minus 0.1. So, Q equals 0.9. So, probability of a defective pen P is 0.1 and a probability of non defective pen Q is 0.9. So, how many pens are manufactured? 12 such pens are manufactured. So, N equals 12. So, in the company, in the factory, they are manufacturing 12 pens. So, N equals 12. So, here X denotes number of defective pens. So, you have to remember this, here X denotes number of defective pens. So, now by binomial distribution we have probability function P of x equals N C x P power x Q power n minus x. So, now first case probability of exactly 2 are defective. So, exactly 2 are defective means x denotes number of defective pens. So, P of x equals 2. So, probability of exactly 2 are defective means probability of P of x equals 2. So, put x equals 2 in the formula. So, 12 C 2 n is 12, 12 C 2 P is 0.1 whole power 2, Q is 0.9 whole power n minus x, that is 12 minus 2, that is 10. So, use the calci, we get 0.2301, fix the decimal place to 4. So, we get 0.2301. Now, second case, probability of at least 2 are defective. So, at least 2 are defective means minimum 2 pens should be defective, minimum, that is minimum 2 pens should be defective or more than 2 pens, means we have to take probability of 2 plus probability of 3 up to we have to take probability of 12, because 12 pens are manufactured. So, it is very important thing, probability of at least 2 are defective means minimum 2 pens should be defective up to 12 pens. So, we have to take probability of 2 plus probability of 3 plus probability of 4 and so on up to probability of 12. So, the calculation part will become lengthy, instead of that take its complement. Its complement is 1 minus probability of x equals 0 plus x plus probability of x equals 1. So, the complement is 1 minus probability of x equals 0 plus probability of x equals 1. So, that is 1 minus probability of x equals 0 already sorry, probability of x equals 0. So, put x equals 0, we get 12 C 0 0.1 whole power 0 into 0.9 whole power n minus 0, that is 12, plus probability of x equals 1, put x equals 1, 12 C 1 P 0.1 whole power 1 Q 0.9 whole power n minus x. that is 12 minus 1 is 11. So, use the calci. So, 0.34 so it is 0.341. So, probability of at least 2 are defective means probability of x greater than or equal to 2, its complement is 1 minus probability of x less than 2. So, it is 0.341. Now, third case, probability of none of them are defective. So, none of them are defective means probability is probability of x equals 0, means no pens are defective, that is x equals 0. So, probability of x equals 0 means 12 c 0, 0.1 whole power 0, 0.9 whole power 12 minus 0 is 12. So, now by using the calci 0.2824. In 800 families with 5 children each, how many families would be expected to have first case 3 boys, second case 5 girls, third case either 2 or 3 boys, fourth case at most 2 girls, by assuming probabilities for boys and girls to be equal. So, here 800 families are given, each families are having 5 children. So, 800 families, each family are having 5 children. So, we have to find the expected number of first case 3 boys, second 5 girls, third case either 2 or 3 boys, fourth case at most 2 girls. But here condition is given assuming probabilities for boys and girls to be equal. So, P equals probability of having a boy, probability of having a boy, it is obvious, it is 1 by 2. So, in a family if there is a child, it can be either a boy or a girl. So, probability of having a boy is 1 by 2 and probability of having a girl is 1 by 2. So, now P, that is probability of success, probability of having a boy is 1 by 2, Q, probability of having a girl is also 1 by 2. Now, here x denotes the number of boys in the family. So, here you can also take x denotes the number of girls, but here in the problem we need the number of boys, we have to calculate number of boys in each family. So, we are taking x denotes the number of boys in the family. So, P of x, that is probability function in binomial distribution, is n c x p power x q power n minus x. So, now each families are having 5 children. So, n equals 5. So, do not take 800, it is n equals 5. So, now P of x is 5 c x into 1 by 2 whole power x into 1 by 2 whole power 5 minus x. So, now this implies 5 c x. So, 1 by 2, now add the powers, x plus 5 minus x is x gets cancelled. So, it is 1 by 2 whole power 5, that is 1 by 2 power 5 into 5 c x. So, 1 by 2 power 5 means 2 power 5 is 32. So, 5 c x by 32. So, this is for one family. Now, we have to find with respect to 800 families, that is important. So, I am repeating again, do not take n equals 800. So, in each family we are finding the probability of having number of children. So, n equals 5, do not take n equals 800. So, now we have to find the expected number in respect to, we have to find the expected number in respect of 800 families. So, therefore, so now multiply 800. So, 800 into p of x. So, 800 into 5 c x by 32, 800 by 32 gets cancelled, that is 25 into 5 c x. So, let us take this as f of x. So, p of x is for one family, with respect to one family. So, we have to find the number of probabilities with respect to 800 families. So, multiply 800. So, 800 into p of x, that is 800 into 5 c x by 32, we get 25 into 5 c x, that is f of x. So, first case we have to find probability of having 3 boys. Probability of having 3 boys means f of 3. F of 3 equals 25 into 5 c 3, that is equal to 25 into 5 c 3 is 10, that is 250. So, expected number of boys, expected number of families with 3 boys is 250. So, this is we are calculating for 800 families. So, expected number of families, that is 800 families with 3 boys is 250. Now, second case. So, probability of having 5 girls in 800 families. So, that is 5 girls, we have to find 5 girls means how many number of boys? 0 boys, x is 0, because we are taking x denotes here number of boys. So, 5 girls means we have to take, do not take f of 5, because there x we have taken number of boys. So, it is f of 0. So, f of 0 is 25 into 5 c 0, which is equal to 25 into 1, which is equal to 25. So, expected number of families with 5 girls, 5 girls means 0 boys. Expected number of families with 5 girls is 25. So, third case. So, family is having either 2 or 3 boys. So, we have to find, so third case probability of having either 2 or 3 boys. So, means you have to find number of families having either 2 or 3 boys in 800 families. So, we have to find f of 2 plus f of 3. So, R means you have to add, that is f of 2 plus f of 3, that is 25 5 c 2, x is 2 plus f of 3 means x is 3, 25 into 5 c 3. So, use the calci. So, 25 plus 25, 50 c 2, that is 15 into 10 equals 500. So, expected number of families with 2 or 3 boys is 500. Now, fourth case, we have to find f of 5, we have to find f of 5 plus f of 4. So, here we have to find at most 2 girls, at most 2 girls means maximum 2, that is at most 2 girls means x is 0, x equal at most 2 girls means there can be no girls, there can be 1 girl, there can be 2 girl. So, no girl means 5 boys, that is f of 5, 1 girl means 4 boys, that is f of 4, and 2 girls means 3 boys, that is f of 3. So, f of 5 plus f of 4 plus f of 3, that is equal to 25 into 5 c 5 plus 25 into 5 c 4 plus 25 into 5 c 3, that is 25 into 5 c 5 is 1 plus 5 c 4 is 5 plus 5 c 3 is 10, that is 400. So, I am repeating again, at most 2 girls means there can be 0 girls, there can be 1 girl, there can be 2 girls. 0 girls means 5 boys. So, we have taken f of 5, 1 girl means 4 boys, we have taken f of 4, 2 girls means 3 boys. So, we have taken f of 3. So, we have to add all the 3 cases, f of 5 plus f of 4 plus f of 3. So, we are getting 400. So, expected number of families with at most 2 girls is 400. So, fourth case is very important. So, you have to be very careful while calculating.